This is the mighty dinosaur, Tyrannosaurus rex, feasting on a triceratops. Can any of you tell me what the word dinosaur means? Yeah.
Terrible lizard.
Very good. This dinosaur scene is based on evidence found in Hell Creek, Montana. Museum paleontologists traveled there and found fossil evidence of so many different kinds of dinosaurs. Way in the back.
We are fascinated by dinosaurs. Ever since we first dug up their bones almost 200 years ago and reconstructed their appearance, they have captured our curiosity. We imagine them walking the earth, dominating all without challenge. How then did these great beasts die?
We're going to talk about the connection between space rocks and dinosaurs. These are rocks that fell from space.
Like a shooting star?
Pretty close. Shooting stars are something we call meteors, which are small rocks that burn up in the Earth's atmosphere. When a rock is bigger and it's pulled through the atmosphere, sometimes it doesn't burn up all the way, and then it becomes a meteorite when it hits the Earth. Take a look at these meteorites.
Awesome. Oh, cool.
Comets, asteroids, and meteoroids. This is the leftover debris from the formation of the solar system, the rock and ice that never fell into the sun, planets, or moons. Early Earth was constantly bombarded by this debris when it was a hot young world, some 4.6 billion years ago. Though the collision rate slowed, these impacts have greatly affected the direction of life on our planet.
This is the Trenton meteorite. It landed right here in Wisconsin. Try lifting it. Careful.
Whoa, this is really heavy.
It is heavy. It weighs almost 30 pounds. Now, the story of the link between space rocks and dinosaurs started a long, long time ago.
Miss Hobley?
Yes, Maddie?
Did an asteroid really kill the dinosaurs?
Did an asteroid really kill the dinosaurs? Yes? No? Maybe? To find the answer, our story starts with Earth. As it orbits the sun, our planet plows into tons of debris. As these tiny pebbles and dust grains descend through the atmosphere, some up to 40 miles per second, they streak across the dark sky. We call them shooting or falling stars. Bigger rocks produce more friction and more heat. They make amazing bolides or fireballs. These cosmic fireworks happen constantly. Every day, almost 1,000 tons of space dust collides with Earth.
Wow, really?
Who are you?
I'm Maddie. I decided to watch the show up here. Who are you?
The narrator. You know, the adult authority figure.
Cool, that works. Carry on.
Okay, where was I? Oh, yeah. Every so often, we hear strange stories of large rocks colliding with Earth. In 1911, a meteorite tore through a barn roof in Kilbourne, Wisconsin. In 1954, a lady in Alabama was hit in the hip after the rock ricocheted around in her bedroom. In 1982, a car in Peekskill, New York, suffered severe cosmic damage. In 1984, a Martian meteorite was found in Antarctica. And 12 years later, it was thought to contain evidence of small bacterial life on Mars. It made big headlines, though it turned out not to be life. bigger collisions have had more severe consequences. In 2013, in Chelyabinsk, Russia, a 70-foot space rock plowed through the bright winter sky. Many cars filmed the bizarre sight with their dash cams. The rock got so hot and built up so much energy, it exploded before it ever hit the ground. However, the shock wave was so powerful, it blew out windows all over town. Over 1,000 people were hurt by the flying glass. In 1908, a huge comet fell over Tunguska in remote Siberia, Russia. Since no meteorites were ever found, astronomers surmised the comet exploded and incinerated 5 miles above the ground. The blast was so powerful that trees were flattened for 20 miles in every direction. There were no known casualties. If this explosion occurred over a major city, the loss of life would have been devastating. If we go back further in time, we discover larger impacts. About 50,000 years ago, a huge rock, about half a football field wide, created this crater in northern Arizona. It's almost a mile wide and as deep as a 50-story skyscraper. The energy at impact was so fierce, so hot, that the nickel-iron meteor was almost completely vaporized. Only a small amount of meteorites were found.
Wow. That is a huge crater. I want to go there. Where is it again?
Arizona. They have a cool museum, too. The next crater we are going to explore is in western Wisconsin. The asteroid struck some 470 million years ago. Way back then, of course, Wisconsin was not today's Wisconsin. It was a shallow sea located near the equator.
We're standing at the edge of a huge asteroid impact crater that's about 4 miles across. This road leads down over the edge of the crater, and it goes up to the skyline on the other side, which is the other side of the crater. So the crater circles around here about 4 miles across. Now, the asteroid hit about 470 million years ago.
It's amazing that evidence for this crater still exists today. Geologists have found uplifted rock around the rim of the crater. The steep angles indicate that the rocks were pushed up during the asteroid impact. This was not caused by continental drift or volcanoes. The clincher, however, was found back in the lab. By looking at the rocks under a microscope, the evidence was seen: shocked quartz. These quartz grains reveal lines that are only produced by powerful impacts. Rain and erosion have erased most of Earth's craters. But as we move out into the solar system, we find craters almost everywhere. Mercury, Venus, Mars, the asteroids, and there are craters on the moons of Jupiter, Saturn, Uranus, and Neptune. And let's not forget Pluto. These incredible new images of our favorite former planet show vast ice plains and mountains, and plenty of craters. The nearest reminder that cosmic bullets have left their mark is our own moon. Though barren and bleak, our closest neighbor is still a stunning landscape. Even stranger, impact detectives discovered that our moon was born from the Earth. 4.6 billion years ago, a mammoth asteroid crashed into a young Earth. The wreckage blasted into orbit and slowly condensed to form the Moon. The early solar system was a shooting gallery. Rocks fell like rain. After hundreds of millions of years, it slowed down, but collisions continue, as we have seen. Back in 1994, a comet broke apart and crashed into the gas giant Jupiter. The most startling fact? It was the first time in human history we knew that an impact was going to occur ahead of time. Saturn's rings are always impressive. They look like a rocky asteroid belt, but they're actually icy boulders, over 90% frozen water. One long-ago collision on Saturn's moon Mimas left a rather distinctive crater. Many Star Wars fans like to call this one the Death Star Moon.
Space is freaking awesome.
Freaking awesome?
But when are you going to talk about dinosaurs?
Right now. Let's go. Dinosaurs ruled the Earth for over 150 million years. They mark the Mesozoic era, the age of the reptiles. They range from small, quick dinosaurs like Sinosauropteryx to the bulky plant eaters like hungry Apatosaurus, who could eat 1,000 pounds of plants a day.
That'd be one gigantic salad.
And there are the mighty meat eaters like Tyrannosaurus rex, who could eat 500 pounds of meat in one bite. That's like 150 pizzas.
Whoa! What an appetite!
Yep, these remarkable reptiles were at the top of the food chain.
Could one asteroid wipe them all out? It seems impossible.
It does. But 66 million years ago, it happened. A huge asteroid 6 miles across was on a collision course with planet Earth. The dinosaurs, of course, had no idea and no chance. Not only was this rock huge, it was moving incredibly fast, carrying a tremendous amount of kinetic energy. The Earth's atmosphere slowed it down, but only very slightly. The asteroid slammed into the Earth at almost 20 miles per second, releasing a barrage of deadly forces. Much of the ejected debris fell back to Earth, a blizzard of meteors. The heat pulse they created was intense, equivalent to a hydrogen bomb exploding every few miles. Oven-like temperatures were everywhere. After the fires, smoke, dust, and gas rose into the atmosphere and blocked sunlight. An impact winter descended on the devastated planet for months. Photosynthesis stopped. Only small animals survived by burrowing underground. The dinosaurs, and over half of all living species, perished.
Incredible. But how do we really know this happened?
The first evidence came from Italy, our next stop. Down below is the small Italian village called Gubbio. It was here, just outside of town, that the shocking discovery about the asteroid impact was unearthed. In these rocks, back in 1977, the father and son team of Luis and Walter Alvarez found a thin layer of clay with a high concentration of iridium. Iridium is a heavy element and very rare on Earth, but more common in asteroids and meteorites. The Alvarezes were the first to find the iridium, and since then, other scientists have found this thin clay layer at more than 100 places around the Earth. They also uncovered plenty of shocked quartz, which, remember, can only be formed by enormously powerful impacts. The connection to asteroids is that asteroids have plenty of iridium. When that asteroid hit 66 million years ago, the impact was so blistering hot, most of the asteroid just vaporized, turned to gas. The hot gas debris shot into the atmosphere, condensed, and slowly fell back to Earth. But the fallout stretched all over our planet and is preserved in the clay layer we see today.
This rock is from Montana. It records the end of the age of dinosaurs. Dinosaurs are found abundantly as fossils in rocks below this layer, but this layer records the end of the age of dinosaurs. Here, we find fossils, but they're usually...
This layer of iridium-enriched clay is called the KT boundary, or KPG. K is for Cretaceous, and PG is for Paleogene. At this point in time, the entire history of the Earth changed. There are no dinosaur bones above this line, only small mammals, some sea creatures, and a few birds, which evolved from earlier dinosaurs, so in one sense, dinosaurs were not completely eliminated.
Is there a big crater from the impact that killed the dinosaurs? You know, like the one in Arizona?
There is, but this discovery took skilled detective work. The crater is well hidden, but they found it underground, in Mexico. It's huge, 100 miles wide. It's the smoking gun evidence for the immense impact 66 million years ago. Today, it's called the Chicxulub crater, named after the nearby town. These are three-dimensional, underground maps of the Chicxulub impact site. The ringed crater is now buried under 1 kilometer of sediment.
Narrator?
Yes, Maddie?
All this asteroid and comet collision stuff, it's kind of scary.
Yes, it can be scary. But we are taking steps to prevent future collisions. There are telescope programs in place that search for asteroids and comets that might have Earth as a potential target. Anytime we study space, it helps us understand the bigger picture, like the origins of our solar system or finding exoplanets around distant stars. In the future, if we start to live and work in space, asteroids will be crucial. Asteroids and comets can be used for rocket fuel and construction materials. Near Orion the Hunter is the galaxy NGC 1232. Though light is the fastest thing in the universe, the starlight from this galaxy still takes 66 million years to reach our eyes. We are looking 66 million years into the past, the same time the dinosaurs went extinct. Looking at a dinosaur fossil is another way to journey back in time. They both give clues to help us discover what the Earth and the universe were like millions of years ago. It just doesn't seem real that an asteroid could really wipe out the dinosaurs and many other living creatures. But all the evidence, the worldwide fallout from the Chicxulub crater, the iridium layer, and the shocked quartz, all point to a 6-mile-wide asteroid killing the dinosaurs.
They may not know all the details, but the scientists have me convinced that an asteroid killed the dinosaurs. What do you guys think?
I think so too, but scientists can find something new and it can change everything.
That's right. That's the very core of science, is being open to new ideas. But right now, all the evidence points to a really big asteroid.
Miss Hobby.
Yes?
If the asteroid never killed the dinosaurs on Earth and it just soared on, would we all look like dinosaurs?
That's a distinct possibility. Dinosaurs ruled the Earth for 150 million years. What's to say they couldn't last another 66 million? If you guys were all dinosaurs, what kind of dinosaur would you be?
We are all fascinated by dinosaurs, kids and adults.
Kids mostly.
Maybe, but I haven't outgrown my dinosaur phase.
Dinosaur phase? What's that?
But nothing. It just means I like dinosaurs.
Me too. They're pretty freaking awesome.
Freaking awesome indeed.